So in section 9.1, we're going to discuss radicals and radical expressions. We're going to go a little bit beyond what you might be used to. Now, I think most of us are comfortable with radicals to the point that if I gave you the square root of 49, that you could figure that out. Probably without taking out your calculator or looking at the left-hand side board. All together? 7, yay. Okay, but really what happens when you're working with square roots is the square root of a number is a number whose square equals a. So it's something that I can square to get what's underneath the radical. So what if I said -7? Would that be okay for the square root of 49? If you square it, you get 49, so sure. Now, to avoid confusion, what we'll do is this. If I want +7, I'll write this. If I want the negative square root, I'll put a negative out in front. Now, sometimes, not maybe so much in this book, but for me, I'll use this, plus or minus, meaning I want both. So, ±7 here. Now let's play around with a few more things with radicals. Take a look at problem number 28, for instance. Square root of 4 over 25. Well, what we can do with multiplication or division is break it up. You can't break up a radical across addition or subtraction, but you can across multiplication or division. So I'll break this up. Square root of 4 over 25. Sydney, how would that simplify? Good, 2 over 5. Now how can we check that? If we're like, just I'm not comfortable with it. I don't know. How would you check that? Yeah, if you square it, if you multiply the whole thing by itself, 2/5 times 2/5, we get 4 over 25. So it checks. This is a number that when we square it, we get what was underneath the radical. By the way, what's underneath the radical is called the radicand. That's the fancy word for it. Not that I'm going to quiz you on it, but if you have occasion to read it, or if I might use it, then that's what's under the radical. Yeah, so in this case, the 4 over the 25 is the radicand. That's what's under the radical. Like over here, 25 is the radicand, and then numerator 4. Okay? A couple more. Now, time to get acquainted with your calculator. Problem number 30. Unless you can do this one in your head. So, take out your calculators. If you need to borrow one, come on up. You should be able to take the square root of 0.16. Go. We'll take a look at this maybe a couple ways. For me, on my calculators, the radical is right above the squared key. So to get there, I have to hit the second key and then the squared key. So second and then the squared key gives me the square root of 0.16, should be 0.4. Yay. Let's see if we can't make sense out of this in a different way, though. Is everyone able to get the 0.4 off their calculator? Yeah? Good? All right, thank you. So 0.4. Another way to see this, if you were stuck without a calculator, because this one works out good, is to write 0.16 as a fraction. So there's 1, 2 decimal places, so I'll divide by 100, and that's 16 over 100. And like problem 28, I can separate that into two pieces. Square root of 16 over square root of 100, or 4/10, 0.4. If you're going to write it like this, I'd probably prefer it in lowest terms, 2/5, but it's still 0.4. Let's try problem number 32. negative the square root of negative 49. This one's a curveball. It's tempting to say negative 7, but let's see. What we want is something that when we square it, we get negative 49. So, well, negative, but if it was a negative times a positive, then you're not squaring it. You have to multiply something by itself. So what's going on here, I mean, you can try a couple things. You can try negative 7. When I square that, I get positive 49. If you take positive 7 and square that, you still get positive 49. Oops. 7. So basically, there's not a real number that satisfies this. And in this class, we abbreviate that. I call it NARN. For reasons unknown, it has not caught on with the wider math community, but in this class you can get away with NARN. In fact, if you write NARN on the right problem, you might be given an extra credit point. So, in any case, some of these things you just can't do. It's not to say that there's nothing we can do, it's just that it's not part of this course. We'll figure that out in Math 1150. For now, let's do a couple more that work with our calculator, and then we'll step it up a little bit of a level. Problem number 36, square root of 340. Now, if I assign a problem like this in class or on a test, I'd really have two goals. One of them is to make sure that you can use your calculator to get square roots. You should get something a little bit above 18. And the other one is to figure out how well you can round numbers. So chances are, on a problem like this, I would ask you to round this to the 4th decimal digit. That's the 10,000th place right there. So you look in the 10,000th place and then you look 1 to the right. What's the rule on rounding? Higher than 5, add 1. If not, then you just truncate it. You just throw out whatever's left. So this is approximately 18.4391. But if I ask you to round it to a specific digit, then I'm asking you to take the time and be careful about where you round it. I'm also going to give you a point of credit for rounding it correctly. That'll be part of the problem. Why don't you try problem number 38? Same kind of thing. Square root of 0.0063. Micah, what's that round to, please? If I'm going to round this to the nearest 10,000th place. Good. 0.0794. Thank you. All right, so a little bit of practice there with rounding some numbers. One that, let's see. Just one other kind of similar example along this line. If I had 0.00796, if I was rounding to the nearest 10,000th place in this particular example, then you got to be a little bit careful. When you round here, what happens? Yeah, you get a carry. So it's 0.0080. And you have to write that 0. If I'm asking you to round to the nearest 10,000th place, there has to be something in that decimal digit. Okay, so let's move on a little bit and dig deeper into radicals. And, I don't know if you want to take exactly notes on this part or not. I will show you a conclusion, but let me start out with something simple like this. The square root of 6 squared. Now, what is 6 squared? 36. And the square root of that is 6. No big deal there. How about if I started out with negative 6 and squared that? I still get 36, and the square root is still 6. So what's the point? Well, the point is, it doesn't matter what I start out with. If I start out with 6 or negative 6, square it and then take the square root, I end up with positive 6. I end up with positive 6 either way. So here's the conclusion I want you to know. The square root of x squared is not just x. If you're being very careful and mathematically formal, then we've got to do something to guarantee that that x is positive. And I'm not trying to signal touchdown here. I'm trying to throw this information into your head. What do you think we could do to guarantee that this is positive? Not the plus or minus. Ah, there you go. Somebody got it. Absolute value. Well done. Yeah, the absolute value. So if you're being careful, then these things should be simplified with the absolute value of x. Because when you take the absolute value of something, you're going to get a positive number, period. So let's see a couple examples of that. We'll start with problem number 40. But looking back at this one more time, this is the result that you should know. Problem 40 gives us a chance to apply this. Square root of 64. I'm going to write that as an x squared. Their t's look, or at least my t's look too much like pluses. Now, I said this earlier. You can break up square roots if you have multiplication or division. You can't do it for addition or subtraction. But with multiplication, I can break this up as the square root of 64 times the square root of x squared. Okay, cool. What's the square root of 64? 8. What's the square root of x squared? Absolute value of x. Good. Need that absolute value. So it's something we're going to have to get comfortable with here. Let's try another one kind of like this. And that'd be problem number 48. The square root of b squared minus 14b plus 49. Now, I've said it a couple times verbally, but let me demonstrate exactly what I mean. One thing that you cannot do with radicals is break them up over additions or subtractions. You cannot say that this is equal to the square root of b squared, the square root of minus the square root of 14b plus the square root of 49. If you did that, you'd be making it very easy for me to grade, if you know what I mean. So what can you do here? We can factor this. And this factors as b minus 7 times b minus 7. Now, a long time ago, I tried to encourage you to do something with this kind of factorization. Good. Write this as something squared. Square root of b minus 7 squared. That's what I tried to encourage you to do. So the idea back then, and the idea is now, is if you write it as something squared, we can finish simplifying this. Jess? b minus 7 is part of it. But if this is a 3-point problem, you get 1 or 2. What's the whole thing? Absolute value. We need that absolute value. When you take the square root of something squared like that, if it has a variable, then you need the absolute value. We don't need it for numbers. 6 is positive. I don't have to write the absolute value of 6. I do need it for the variables. Okay. So let me give you a couple to try. We'll do problem number 50-ish. I'm going to change it a little bit from what the book has. Square root of x squared plus 10x plus 25. And problem number 44-ish. Square root of 9y squared. I've changed these problems a little bit from what the book has. That's why I put the ish there. Okay, so first thing we'll do here is we'll factor that. That factors is x plus 5 times x plus 5, or better yet, the square root of x plus 5 squared, which is the absolute value of x plus 5. How about over here? Break this up. Square root of 9 times the square root of y squared. Make sure you take the square root and then get rid of the square root. Sometimes people forget to leave off the square root. Square root of y squared is the absolute value of y. Nice. Let's take a quick look at the real problem number 44. They have the square root of 9y to the 4th. To the 6th? Oh. Alright, so this is another problem 44-ish then. What if I had the square root of 9y to the 4th? Well, I'd do the same thing I did up above. Square root of 9, square root of y to the 4th. This is the 3 as before. And you can say, oh, well, gee, that's the absolute value of y squared. But let's think a little bit about the y squared term. When you square something, what's its sign? When you multiply a number by itself, can you get a negative number? It's always positive, right? So if this is always positive, well, you really don't need the absolute value. So you wouldn't have to write it there. You know, I'm not sure I'd really want to see the absolute value there. I mean, I'd feel a little divided. I'd be happy that you're conscientious and remembering the absolute value, but we don't need it here. So I generally don't put that kind of problem on a test because I feel like it's a little bit tricky and I don't want to have to decide, gee, should I give them a point or no? Yes? Well, you're looking for what you square to get this. So essentially what you're going to do is ask yourself, what do I multiply by itself to get y to the fourth? In Math 1150, we'll learn a little bit more about why this happens, but let's look at it this way. I want something that I square to get y to the fourth. So it's a matter of, well, gee, what do I multiply by 2 to get 4? And the answer is 2. Yeah, we don't need the... Now, in general, when you have, say, y to some power, then what you'll do is divide that power by 2 when you're taking square roots. So the last version of this was square root of 9y to the 6, square root of 9, square root of y to the 6. By my little shortcut here for you, you take 6 and divide it by 2, because we're dealing with a square root, and you'll get y to the third. And here you actually would need absolute values, because when you cube something, it still could be negative. All right, that's not typically what I quiz people on. What I want you to know is this, and I'll be explicit about a little bit more that I want you to know. For now, let's move into higher order roots. And by that, I mean cube roots and fourth roots, etc. Higher power roots. Problem 72 gives you this. So you have a 3 out in front here. And the 3 out in front simply signifies that this is a cube root. We need to find a number such that the cube of this number equals 8. So what do you cube? What do you multiply by itself 3 times to get 8? 2. Now if you look at the left-hand side board, somebody who plays hockey, goes skiing, and brews beer, left, I don't know, he's anonymous, but he's a cool guy, left not only the first 20 perfect squares, but the first 10 perfect cubes for you there. So it's kind of nice. It's a little bit of a help here for you. Cube root of 8 is 2. And you can see some of the first 10 perfect cubes up on the left-hand side board. It's funny. Years ago when I was teaching this class, people would take and write them down in their notes. You know what they do nowadays? Take a picture of it. Just take a picture of it. Put it in their phone. All right. It's not a bad idea to have around. We're looking for things that you can cube to get these numbers. So an immediate difference here is something like problem number 74. The cube root of negative 27. This is no longer narn. Narn is not the right answer for this one. There is a real number that you can cube to get negative 27. Can anyone tell me what that would be? 3 cubed is 27, not negative 27. Negative 3. Yeah. So the thing about cube roots is that you can deal with negative numbers here. Now sometimes these cube roots are for numbers that are a little bit bigger than what you're used to. Maybe you don't have that list memorized yet. That's certainly understandable. So it's helpful to be able to figure out how to do these things on your calculator. And I can show you mine. I'll walk around and try and help you out with yours. For the graphing calculators, go to the Math menu. The fourth option down is for cube roots. So let's do the cube root of, say, 512. Should give you 8. Like I said, I'll walk around. If you're having problems finding your cube root key on your particular calculator, try and flag me down. Spend more money. Way out of not money. All right, you're not going to use that on the test, just so you know. All right. This thing is quite a lot. It's still cool. This is my first all good? Rest of the way around? All right. Over here. Second button and then that button. You're not doing it on your phone, right? Yeah. Okay. Is that a calculator? Okay. Yeah, well, it looks like a phone. It's too funny. They're trying to mess with me. Okay, so let's do a couple more here. Problem number 80. Cube root of negative 512 x cubed. Well, this is a multiplication. You can break things up over multiplication. So it's the cube root of negative 512 and the cube root of x cubed. Now for your number parts, you can get that off your calculator. We just finished doing the cube root of 512 though. So what's the cube root of negative 512? Negative 8. Good. As far as this part is concerned, the trick here is kind of like our trick with the square roots. With square roots, we had a number 2 out in front that is never written, but it's kind of implied. With cube roots, we got a cube out here. This exponent divides that exponent. 3 divided by 3 is 1. So negative 8x. You don't have to put the 1. In fact, I'd rather not see the 1. No, it's a good question. You don't have to use the absolute value on this. And I'll talk in a moment in general about, well, when do we need the absolute value? Because it's a good question. Problem number 82. Cube root of negative 343 a to the 6th, and I'm going to change this up a little bit. A to the 6th. Let's do b to the 15th. Okay. Timer?
Just ask kind of question. Does it work to make any cancellations on those square roots?
No, you're not really making cancellations. Not really. You're taking the cube root. So, I mean, there is kind of a cancellation if you're thinking of 3 divided by 3.
What I mean with the powers.
No, you can't. Yeah. There's no shortcut like that. Yeah. Appreciate the question, though. Karanja, what'd you get for the cube root of negative 343, please? Some help on that one there? Ted? All right, so negative 7. How about this one? Cube root of a to the 6th. A squared, good. And Andrew, the last one. Cube root of b to the 15th is b to the 5. It's 15 divided by 3. So, nice. No absolute values to these. Correct. Yeah. And like I said, I will talk in general terms in a minute about when you use the absolute value. Let's do a couple more here, and then we'll get around to what I've been promising you, which is, well, when do I need the absolute value? And these are even higher order roots. So, problem number 88 is the 6th root of 64. Now, for those of you who are tempted to look at the left-hand side board, I'm sorry, my list stopped at cubes. I didn't do 4th, 5th, or 6th. So, how do we do that? Well, I can show you on the graphing calculators. Sorry about that. So, you're going to hit the math key. This time, you're going to go to the 5th option down. Actually, you know what? Let's scratch it. We got to type in the number 6 first. So my bad. Hit the 2nd key and then the mode key to quit out of there. Type in the number 6 first, then hit the math key, then the 5th option down gives you kind of like an arbitrary root. 5th root, 6th root, 7th root, whatever you need. We want the 6th root of 64. And it's 2. Can you verify that? Sure. 2 to the 6th power is 64. So it checks. It's a nice double check of your work there. Make sure you can get these higher order roots. I know some of you have a little key built in for 6th powers. We can do number 90 next. Negative the 4th root of 625. What I would suggest is just leave the negative off till the end. So kind of regard it like this. Let's focus on the 4th root of 625, and then just realize that your answer is going to be negative. We want the negative of that one right there. So again, I'll walk around, try and help out. If you're struggling, let me know. Okay, so your answer here should be -5. Is everyone able to get that? Yes. So a good question that's kind of been coming up here and there is like, well, when do I need to use the absolute value for problems like this? When do I have to remember the absolute value? When don't I? And it's a little bit more general than what I'm going to hold you responsible for. But let me discuss that. When do I need to use the absolute value? It's a fair question. Well, there's two cases that we're going to discuss. And the two cases that I'll hold you responsible for. The nth root of x to the n equals the absolute value of x if n is even. Well, there's two things going on. The first one is that these two things match. The second thing is that they're even. If they're even, then you need to use the absolute value. What about this case? If n is odd, then you don't need to use the absolute value. But again, these two exponents have to match. The power of the radical, which is the number outside, equals this exponent, which is on the inside. If they match, and this is an odd number, 7, 9, 11, 17, 29, etc. If it's an odd number, then you don't need the absolute value. If it's an even number, you do need the absolute value. So, with that in mind, let's look at two examples. Let's do the fifth root of 32a to the fifth and the sixth root of 64y to the sixth. Now in both of these, what I'm looking to see you do is simplify the radicals. Since you have a product here, you can break these up. Carefully use these ideas about when to use the absolute value and when not to use the absolute value. Let me give you a few seconds to work on that, and then I'll have you compare notes with a neighbor. Okay, so turn to a neighbor and see if you agree. See if you agree how these simplify and whether or not you need to use an absolute value on one, the other, or both. But turn to a neighbor, make a friend. Take this chance to interact with your fellow human beings. Megan, Jackie needs a friend. Ted, you got a friend? Okay, all right. Yeah, I'm pretty sure. Okay. Who's confident in their answer? George? Confident? How about the first one? Fifth root of 32 is Fifth root of a to the fifth is a. Do I need the absolute value on that one? No. Is he right? Yes. All right. Good. How about the next one? Who else is confident? What do we need here?
2 and the absolute value for y.
Good. 2 and the absolute value for y. Notice we don't need the absolute value around the 2's, just around the variable part. And that's fine. Let's do maybe one last one like that. Problem number 112. Square root of 169, p to the fourth, q squared. Like I said, it's not really often written, but it's understood that there's a 2 out in front. Okay. Oops. Square root of 169, square root of p to the fourth, and square root of q squared. We'll start here. Square root of 169, 13. Square root of p to the fourth, p squared. Now, if we can put the absolute value around it for just a second. Square root of q squared, q. Now, p squared is already positive. When you square something, you get a positive number. So I don't really need the absolute value around the p squared. I do need the absolute value around the q. So that's the way the book would write the answer. Around both of them, like yeah, you know, I'm not going to be too much of a stickler on this. If you wrote absolute value of p squared q, is that what you're thinking? I suppose. If you, it's not really wrong. It's just, I don't know. It's from being a mathematician too long. It's like it offends our sensibilities. It's like, oh, you don't really need it there. But I'm not going to be trying to bust you guys on something like that. I'd be happy to see you guys remember the absolute value. Last, yes. Well, the 2 is understood to be out in front. You don't have to write it. Just like the y here, even though it's not written, it's understood to be y to the first power. But you don't write it. Same thing with square roots. Square root of 169, sorry about that. Square root of 169, typically we'll write it as like this. And that's actually a 6 there. Typically you don't write the 2 out in front. It's just understood. Now for anything else, you do have to write it. So if it's a 6 power or something like that, then you have to write it. Notice this 6 power is here and here. You can't just leave it off. So good question. Tomer, you had a question as well?
Yeah, so 112. You got the absolute value on q.
Yes,
So
and you can't get rid of that.
power of 1.
Yeah, even though it's not written, it's understood to be q to the first power.
So it's an odd.
Right, so that's why we can't get rid of the absolute value.
It's an even number, so we use it.
Yeah, so these two match, and it's an even number, so you have to use it. Now, you bring up a great question, and it's a good little teaching opportunity here for me. If you look back at this one, you've got the square root of p to the fourth. Is that a case that's covered by this little thing that I gave you here? Not really. What has to happen in order to use this rule is that these two things have to match, don't they? And these don't. That's p to the fourth. And no, in order to use this rule about when you use the absolute value, then these things have to be the same. 2 and the 4 are different, so this rule doesn't apply. It's not to say that it does or doesn't have an absolute value. It's just saying that, well, you know, this doesn't tell us what to do here. That's all.
So I have to have both of the powers is the same.
And even in order to use the absolute value. So a good example, and you're leading me where I want to go, is problem number 114. Sixth root of x plus 4 to the 6th power. And the last one I'll throw in here is number 116. Sixth root of negative 1. What haven't I heard yet from yet this morning? Volunteer for number 114? Don, thanks for volunteering. What are we going to get when we do the 6th root of x plus 4 to the 6th power? Do we agree with that? X plus 4? Ah, you need the absolute value. This is what we were just talking about. If these things match and they're even, you need that absolute value. Okay. Let's move over to this last one here. Maybe it'll be our last one. I don't know. I was hoping for some consensus on this one, but let's take a look at 116. Any ideas there? Ah, good job. It's not a real number. You can't raise something to an even power and get a negative number. And watch what happens. If you thought, gee, maybe negative 1 works. Negative 1 to the 6 is negative 1 times negative 1, total of 6 times. But when I multiply that out an even number of times, what's going to happen to the negative sign? Yeah, it becomes positive. It cancels out. So when you raise a negative number to an even power, you're going to get a positive number. You can't get a negative number, so you can't do an even root of a negative number. Yes, sir. If it was a 5th root, then we'd be in business. Let's take a look here. It's a great question. 5th root of negative 1 would be negative 1, and we can check it. Negative 1 to the 5th is going to have an odd number of negative signs, and when we multiply it together, you do get negative 1. So, kind of a parting shot here for you. If you have an even root of a negative number, you're going to get NARN. This is extremely informal. I can see some of my colleagues really cringing that I would write this, but that's in general. I mean, for you sitting there, I mean, that's what it means. Is if you've got an even number out here and a negative number here, it's just not a real number. You can't do it. Okay? All right. Let me give you some homework. 23 through 41, 49, 63 and 65, 71 through 81, and 97.